Alright, y'all, today we have a pretty short lesson on the remainder theorem. First of all, before we really get into this, if you don't feel confident with using synthetic division to divide polynomials, you may want to review that really quick before you start here, because we're just going to use that here a bunch. And this is actually the reason why synthetic division is going to be really useful for us. Okay, so I'm just going to jump right out with it. This is one of our only theorems that we'll call a theorem this semester, called Remainder Theorem. If f of x is divided by x minus c, then the remainder is the value of f of c. Okay, how can we use this? Example, let's say we have f of x equals some polynomial 2x cubed plus x squared minus 13x plus 6. Use synthetic division and remainder theorem I'm going to shorten that to THM to find f of negative 1 and f of 2. Okay, so what does remainder theorem tell us about these things? Well, if we are looking for f of negative 1, remainder theorem tells us that to find f of negative 1, we just have to divide f of x minus c here is negative 1, so minus negative 1 or x plus 1, and the remainder of that will be the value. Or normally to divide a polynomial by some other polynomial, we would have to do polynomial long division. But fortunately for us, we have this form x minus c that allows us to do synthetic division, which makes it way easier. So synthetic division, let's set it up. First, working with negative 1. First, let's think about what our c value is going to be. So this is something that's a little bit confusing for folks. Do we use positive or negative 1 in this case? Well, remember, we're looking for f of c, which is x plus 1, right? When we're given the factor to divide by, when we're given a divisor of x minus c, then in order to find c, of course, we have to use, positive c, which means we have to flip the sign. But here we're given c. So here, c is negative 1. A lot of times folks will make the mistake of flipping the sign too many times, right? So here this means that we're looking at the factor x minus negative 1 or x plus 1, right? So negative 1 is what goes in our corner. We follow with the coefficients of what we're dividing by. So we have 2, 1, negative 13, and 6. Our first step is to bring down the leading coefficient. Then we multiply, so we get negative 2. We add the column up, so we have negative 1. Negative 1 times negative 1 gives me positive 1. Negative 13 plus 1 is negative 12. Negative 12 times 1 is positive 12, and 6 plus 12 is 18. So, what does this tell us? Well, remainder theorem tells us that f of c, or f of negative 1, is equal to 18, right? The remainder. Cool. All right. That's f of -1. Now let's look at f of 2. So here c is 2. That means we are looking at what happens when we divide by x minus 2. 2 goes up here in the corner. We write out our coefficients. We bring down the leading coefficient. We multiply, we get 4. We add up, we get 5. Multiply again, we get 10. We add up, we get -3. We multiply, we get -6. And we add to get 0. Okay, so our remainder here is 0. Remainder theorem tells us that f of 2 is equal to 0. Really quick before we move on, when the value of a function is 0 at some point, what does that mean about that point? It means that that point, which is in this case 2, right, x equals 2, is a root of f of x. And if 2 is a root of f of x, what does that say about x minus 2? If 2 is a root of f of x, then x minus 2 is a factor of f of x. So if x minus 2 is a factor of f of x, that means that we can write f of x in the following way, right? We can write it as this factor times the quotient, whatever it is, right? What is the quotient here? We use these guys, right? Those are our coefficients for our quotient. Again, if that feels unfamiliar, definitely go back and watch the last video on dividing polynomials. It'll be at the sort of the second half of the video. I talk about synthetic division and I explain all of this. So we have 2 something plus 5 something minus 3. Minus 3 is the constant because it's the last one, and then we want to work our way up with exponents from there. So we have regular x and then x squared, right? Each term has an exponent of 1 higher. All right, so we have 2x squared plus 5x minus 3. So we've kind of taken this original function that we had, right? This guy, this 4-term polynomial, and we've factored out x minus 2. We've sort of split off a chunk of it, right, and written it this way. So now we have x minus 2 and then the quotient, right, the rest of it. Because our remainder is 0, of course, there's no like plus 0 at the end. I mean, we could write that, but, you know, why? What's the point? No reason to, right? And what's something cool about this is that actually this quotient can factor as well. We can factor this. Of course, we can bring down the x minus 2. And then this quadratic factors into 2x minus 1 times x plus 3. Right? If I multiply 2x times x, I get 2x squared. If I add 2x times 3, which is 6x, to -1 times x, which is -x, I get 5x. And if I multiply -1 times 3, I get -3. So I can actually factor this entire polynomial into these 3 factors here. So we actually found so much information just by looking for f of 2 for this function. And one big piece of information that I'd like to highlight is actually something that we're going to call factor theorem. So our second theorem, this is called factor theorem. if f of x is divided by x minus c, and the remainder is 0, then x minus c is a factor of f of x. Right, we saw that in the example above. We used synthetic division to divide f of x by x minus 2, and we ended up finding out that x minus 2 was a factor of the function. How can we use this? A lot of times the way we'll see this is we're given a function. So let's say p of x equals 4x cubed minus 24x squared minus 4x plus 120. And we're asked, is x equals 4 or x equals 5 a root of p of x? Well, let's see. So let's do each of these using synthetic division. So we start out with 4. We line up the coefficients, so we have 4, negative 24, negative 4, and 120. We start out by bringing the leading coefficient down. We multiply. We get 16. Negative 24 plus 16 is negative 8. Negative 8 times 4 is negative 32. We add that to negative 4, we get negative 36. Then we multiply negative 36 by 4, and we get negative 144. Then we subtract these guys. We end up with negative 24. That's our remainder. Negative 24 means that p of 4 equals negative 24. Negative 24 is definitely not 0, so this is not a root, right? So 4 is not a root. Let's try 5. So we've got 4, negative 24, negative 4, and 120. We bring that leading coefficient down. We multiply, we get 20. We add these up, we get negative 4. We multiply, again we get negative 20. We add these up, we get negative 24. We multiply negative 24 by 5, and we end up with negative 120, which brings us to 0. This is our remainder. So we have p of 5 equals 0, which means that 5 is a root. Awesome. Now let's say that after we found this root, we were asked to factor this polynomial all the way. So let's factor it out. Because we know p of 5 equals 0, what is a factor? What is a factor? Well, if c is 5, then we have x minus c or x minus 5. So that means we can write p of x as x minus 5 times the quotient, which is what? Well, remember we find that from our coefficients, right? These numbers that were also underneath the line here. This is going to give us 4x squared minus 4x minus 24. Remember, as we move from right to left, we increase in exponents, right? So we have the constant term, then we have the x term, then the x squared term. If we had another number, right, if there were 4 coefficients, we would have x cubed, and then x to the 4th, etc. It keeps moving up. Okay, so can we factor this? Let's figure it out. if I am looking at this, the first thing before I try to do any fancy factoring stuff, if there's something that I can pull out to make it easier, I should pull it out. What do all of these have in common? 4. So x minus 5. We have a 4 that we can pull out, so times 4. What's left over? Well, this term we're left with x squared. This term we're left with x. And this term, negative 24 minus 4. Negative 24 divided by 4 is negative 6. Can I factor this? Is there anything that multiplies up to negative 6 and adds up to negative 1? Totally. I'm going to write this 4 out front just so that it looks sort of more like what we're used to. So we have x minus 5, and then x, well, negative 3 and positive 2 would give us what we want, right? So negative 3, positive 2. That means that we have what roots for this function? Well, 5, 3, and negative 2. Three roots. The degree of this polynomial is 3. We add 3 factors. Nice, clean, easy function. And we found all of that just by doing synthetic division. That's kind of a sneak peek at our next lesson, zeros and factors of polynomials. We're going to do this a bunch of times with a bunch of different tricks and all sorts of stuff. Hopefully this is making sense, and I'll see you guys next time.